Hi JD, it's Adnan. Hope everything's fine. How are you? I'm alright. At first, I was really worried about the project, but I think we're making good progress. In case I fall asleep, that's why I'm making the video so that you can see what I'm doing on my end. So, remember in the paper, the MICE paper, they are talking about something called GBVS to find image saliency. So I'm going to show you right now what I've done on my end. So I found this implementation online for to compute GBVS or whatever it's called, but and it's I have tinkered around with the code, modified it for our needs, and let me show you what it does, and then I'll show you something more interesting. So here you go. Okay, so uh, this is the original picture. It's a citadel, I think, and this is the GBVS map, meaning this red part is the important part, meaning that's the part we want to focus on in our analysis. And this is another algorithm, and this is called the Quach or Quach. But in reality, when we are going to implement this, I think we will not be using these guys. We'll be using the maps. This white part. If we make a good threshold and make it binary, then we will only have this guy, the bright white part, and over here also the bright white parts. If there are like multiple regions of interest, but I think even if we had more things here, then from the this image we would get this image, and from that we'll make a binary which is like one line of MATLAB code. So this part is the algorithmic part, but and now let me show you what happens, and like more in the more involved way what I did. I wrote a function called draw grid, but before that, let me show you the picture itself. So this is the original picture that we will be working in the example right now. So this is what we have now. Uh, I am actually deriving a matrix, and I wrote this function called draw grid. So in draw grid, well, we are drawing the grid, a 3 by 3 grid, but that's not everything what we're doing here. We are actually getting the coordinates of this point, 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 this point. So how many points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we will have 16 points to find like where those are, and this is dynamic. It can be of any size. I mean the picture. So all that information is in the M. I'm sorry, like my eyesight is getting bad. That's why I make fonts real big. So let me show you. So the M matrix is the matrix where we have the those guys. I mean, uh, I'm let me bring it up quick one more time. So let's have this picture here so that I can show you. So that function has generated this M matrix. So M11. Forget about the third dimension. 1 1 is 1 1, meaning this point. Then If we move to 1, 2, that's 1 to 40, meaning this point. Then if we move to 1, 3, this point, you can see that the row is 1, the column is 480. So we are going in the right direction. And the last point in this line is 1, 4, which is which is 1, 7, 20. So this is this extreme point, and this makes sense because if we look at the size of this picture, it is 480 by 720. So this is happening correctly. So in the matrix is of size 1, 2, 3, 4, 4 by 1, 2, 3, 4, 4 by 4. So over here we should get the result of the actual endpoint, the direction of the size. So let's make this 4, 4, 4, 4. So see, 480, 720. This guy here. And what happens here? Let's see. It's going to be 1, 2, 3, 4. That's like 1, 2, 3, 4. Okay. 4, column number 3. So that's 480 by 480 over here. And on the left of that is 480 by 240, which is this point here. And to the extreme left of the last one is this guy. Now, as for these central parts, this is like, I think this is 2, 2. Let's see, I mean, this here, 2. So that's 160 to 40, meaning it's 160 here to 40 here, because the width is longer. So these have been calculated. So in the next 2 days, what I'll do is I'll use these coordinates to find and use the input of use this as input, the maps, these guys, and look for where we are finding the actual salient regions, and that way we can have a matrix, a metric to measure how well we are doing. And on the database part, I think we do have a line of thought right now, so I'm feeling pretty good about this. I think we will be in good shape. So even if I fall asleep, hopefully you'll get to see the video, and I'll put all the codes on GitHub. So thanks, JD. Have a great weekend.